Yes, thank you. So let's now dive deep into the practical part of embeddings. So we are going to basically construct a vector database. We put in a document, a web article, and then we try to retrieve information. So we are basically passing through each step of the embedding part. Yeah. So we are going to just need this. I will share this in the description. Then you can basically learn it yourself also or use it. Then what I like to do is make my global setups before. So here I'm like importing Orama embeddings. Actually, I need to start Orama. I need to start Orama. Yes. So I'm like importing Orama embeddings from LangChain, DeepSeek, the DeepSeek wrapper, like the DeepSeek package to use. And then yes, this is the embedding model name that you're going to be using. There, I particularly use this one because it's small and it can run on my machine easily. And you're using this model for the main agent. So okay, this is now we are making the embeddings global, and we are defining the embeddings that you're going to use, and then you're also defining DeepSeek, the model that you're going to use. So now this is the meat and the grind. I don't remember how they say it, but basically this is the overview of how a simple RAG automation would work. Like basically, a retriever can be um, can be done. So you see here we have our web page, which is this one, and then we are loading it. We split it into chunks. After splitting it into chunks, we apply embeddings, and then we store it into our vector database. This is what's happening here. We get our document, which is this one. It's about nutrition and athletic performance. Then we look at the web-based loader. This helps us to like put get different chunks of the this is where we are chunking basically. So we get the first page, the first subset of the page, another subset of the sub list of the page, and we just put them in this docs list. Then here I'm trying to apply some more formatting so that we don't get and so that we remove unnecessary parts. So for example here, like remove or replace all new lines with an empty whatever, and the double spaces with a single space, so that we can make it easy. We will see down the line how it goes. Then we had defined our llama embeddings. Now we are defining it here. Actually, this could be replaced by this one. Yeah. And then we do a text splitter. Now here we are splitting the text, and we are then yes, adding an encoding. This why do we do this? Basically, this is initially what we did was to with this part, what we are doing was to split the text. We will see this all was to split only the text. Now here what we are doing is that for yeah, we are getting all the we are no, the text splitter. What is like we are defining the characteristics that we use to when you are going to make like where when you are going to tokenize the texts. So this is where we have like the doc splits now. The doc splits, each doc split is going to be put into like to be tokenized, and then this is going to be the maximum or the length of the token, basically the maximum token we can have, and then the overlap. in this part, so overlap is like this is what we mean by overlap. You can see in these chunks we have different chunks. There is a space in between. Now this space refers to the information that this contains and this contains. So now at you can have, when it's an overlap, it's something that would look like this. So basically now we create it from here. If you say maybe an overlap of 10, then they will share some information, and then this doc split comes and has an overlap with this one. That's one part. Like that's one part. No, that's what we mean by overlap. Then we do doc splits. Yeah, we split the documents, and then we do a vector store. We put yeah, we initiate our vector store and we put in the doc splits and the embeddings to use. Then we retrieve vector store. We initiate now our retriever, so that whenever we need to engage with the vector store, we can just ask it. For example, if you wanted to ask something about like diet, maybe what is protein or something like that, then it's going to do. This is an example of how we use a retriever. So let's just run this. Oh yes, yeah, I like printed the length, so you can see we ask it about the proteins, and it gave us one single document, that it found a single document or a single doc spread that is related to our question. Now let's dive deep now, see what's happening in the background of each thing. So this is how we do like an embedding in a simple sentence. So let's do a small sentence, and you see when we talk about this, you see here embedding is converting. We are converting it into a vector. And remember that for this particular part, like think for this one, it has 1024. Yeah, that might be the dimension that it's using. So let's see what happens. On Friday I ate an apple while wearing an Apple Watch. You remember that it has to pass through the vocabulary size. Like it has to compute based on the vocabulary size and its train, and how it was trained, and then determine this relationship. This is the numbers that we are seeing here. These are the embeddings, and you can see for each dimension it has 10 for 24. So this is how many dimensions, so the length of this of the result should be. Yes, now you can see it's so much. Now let's look at how we do our document splitting. And here I'm going to load three web articles. The first basically they are all talking about diet and protein, specifically protein. So here now what we do here, we are loading each URL of the URLs, basically each article, and then we are like loading them each individually now, so that we make it easy to recognize, to get. And then let's look at basically here we are formatting, so we remove new lines. Before formatting, it contains so much new lines, because you can see in an article there are so like new lines to this new line. Even here it takes it like that. Perhaps let's see like one doc, maybe doc list 0. So this is in efforts to how do I say it, to like in efforts so that we reduce the context that we are going to give to we give more clean data to our LLM. So when we need to use our like RAG, or like when we are going to embed, This is so that we move all of these unnecessary parts. So this is where we have, and so this is what we are doing with the formatting. And this formatting is specifically done so that for example, if we are jumping into a new section, we still stay with the new line, but when we are like inside or basically between two pages, we don't need these many new lines. So this is how we are doing something now. If you check this one, for example, you can see that if we try to look at it, let's try to look at everything. Do you see what changed? Sorry, you can see now we do have somewhere the space was needed. We still have it, and at least we tried to clean up, to make a small cleanup. So this is how now what we have so far, and now this is us doing the document splitting and formatting. Okay, so this part is where now we do the part of the splitting, and then we look at the like the chunk size for no, we are doing the splitting, and then basically all the documents that we formatted here, what we are doing now is we are turning them into different doc splits so that we can see we can have them, we can save the splits into our vector database. So you can see that we got 30 splits. Let's try to see if any of these exceeds the chunk size as we try to see. So like we can try to see, let's see if 30 will take so long. But you can see that none of our chunk size text is like higher than 512, like 512. Okay, now this is where we did the stalling part, and then we try to retrieve also how many we did. So something like, and here one thing to note is that by default we apply the Euclidean search. So Euclidean search, this is the default search that is applied. So if you remember, when we are doing the search inside this vector space, we have Euclidean search, which is looking for the distances between the vectors, and then we have the cosine search, which is looking at the angles between the vectors. Now this is where we have our, like when you are searching, you can see we found four splits that are related to our questions. Now we can just dive deep into like the Euclidean search and also the cosine search, and we see what is image search with the relevant scores, and then with this one, and you can see we looked for what is plotting, and you can see we are basically returning this information. But let's look at the page content disclosure helps. Oh, interesting. Anyway, you can see that for this document split we have this information about the plotting. We found these two, like the types of data. So we found some, but you can see at least there is no hallucination, if I would say, like every part contains our query that we are looking for. Now let's see if this provides an improved search. So to the types, if you can see, basically it's almost going to give the same results, nothing much. Cool.